Determine the equation of the oblique slant asymptote for the following functions. Y equals x squared minus 1 over x plus 3. Okay, so in order to do this, what we need to do is divide these polynomials. And the result should look like something of the form of a uh, polynomial plus some uh, quotient or remainder over the original divisor, something of this form. Now the nice thing is the denominator is of the form such that we can use synthetic division. So if I take the factor x plus 3 and change it into a 0, divide it into the quadratic in the numerator, so x squared plus 0x minus 1. Then I bring the 1 down, negative 3 times 1 is negative 3, that adds up to negative 3, and this would multiply to positive 9 and have a remainder of 8. Okay, so that means this can be written as the form. This makes a polynomial of 1 degree less than the original numerator, so this is linear. So it would be x minus 3 plus the remainder of 8 over the original denominator. Now, it just so happens that this linear equation is the slant asymptote. So the slant asymptote is defined by y equals x minus 3. In the next example, we'll do the same. We'll just take the denominator, which is a factor, and write that as a 0. Use that with synthetic division on the numerator, so x squared plus 0x plus 4. And this gives us 1, that adds up to 1. 1 times 1 is 1 again, so that's 5. So this ultimately gives us the linear function x plus 1 plus the remainder 5 over x minus 1. So the slant asymptote here is y equals this linear x plus 1. Lastly, we'll do the same thing again. We'll take the denominator of x minus 5 and write that as a 0, 5. Factor it out of the numerator, so 1, 3, and 4 are those coefficients. Bring the 1 down, 5 times 1 is 5, this adds up to 8. That's 40 or 44. So that we get, this is x plus 8, and then 44 over the original denominator, so that my slant asymptote is just simply at the value x plus 8.